Hello, we have learned the equation of a line in 2 dimensions and 3 dimensions, and also we have learned how to find the point of intersections of two lines in 2 dimensions and 3 dimensions. In this lesson, we are going to find the distance from a point to a line in 2 dimensions and in 3 dimensions. So the distance, it means the shortest. So we are looking for the shortest distance from a point to a line. And we are going to see how we can find it. So this is a point and there is a line. We just sketch it quickly. So -4, 3. Here is a point Q. And also we have a line. We want to rewrite it in the slope y-intercept form by isolate y. So -5x minus 8. So the y-intercept is -8, the b value, and the slope is -5 over 1. Is down 5, right 1, or up 5, left 1. So a little bit here, then we sketch the line. So it will be something like this. Okay. So this is a line. We put arrows at both ends. It keeps going. Okay. So 5x plus y plus 8 equals 0. And the distance from this point to the line is the shortest distance. So it's need to form 90 degrees to the line. So how to find it? We could use is we have learned the projection. If we could find this is Q, so if we have another point, use this one as our P point. So the PQ, this is a vector PQ. PQ projection on the norm. So the perpendicular to the line is a normal. It's a normal for this line. So the projection of PQ on the normal is our shortest distance. So PQ projection on the normal will give us the shortest distance. So this one, if we write it as O, so the shortest distance OQ equals the projection of PQ on the normal. So we could find the normal and derive the formula. The mathematician has done the job for us already, so we could use the formula right away. So if we have a point P x0, y0, and the distance to the line ax plus by plus c equals 0. If we use find the normal, then find the projection, the distance equals, just sub the x0, y0 to the line, then all over the magnitude of the a squared plus b squared, magnitude of the normal. Okay, so we could just use this formula and find the distance. So d equals, we sub in, a is 5, so we just find a equals 5 for this question. B equals no number at front of y, it means it's times by 1. No numbers for multiplication is 1. No numbers for adding, subtracting is 0. So C equals 8. Then the x0 equals -4. y0 equals 3. We just sub all the 5 numbers into this equation. So 5 times -4 plus 1 times 3, then plus 8, all over a squared plus b squared. 5 squared plus 1 squared. So do the calculation is negative 20 plus 3 plus 8 over square root 26. If we don't want to see the radical number at the denominator, we could rationalize it by times if monomial, just times itself. Then we are going to have negative 20 plus 11 is negative 9. F's value give us positive 9. 2 square root times give us square root squared is itself 26, and times square root 26, then it's done. So this is how we find the distance from a point to a line in 2 dimensions. And we could just use this formula right away. If you are interested in the proof of this formula, you can search YouTube to find it. And we are going to see the next one. Distance from a point to a line in 3 dimensions. Unfortunately, in 3 dimensions, we don't have a formula for that. So we have to use a projection, those type of stuff, or cross multiply to find it. So find the distance from a point to a line given by this one. So from this one, we are able to find that we have 1 point on the line is 1, 3, negative 1. The number at front is a point. The number at front of the variable is our direction vector. So 2, negative 1, positive 1. Then we have a point Q. So we have to find this is our line. So I just randomly draw it. So 1, 3, negative 1. Then at this point direction, if t equals 1, we have another point is 3, add together 2, add together is 0. So we could write this point as PQR. Okay, so this is point P, point R, and also we have another point is Q. It's not in scale. 4, negative 1, positive 1. So we want to find the distance from Q to, I may give it another point intersection with a perpendicular is QT. So what we need to find is magnitude of Q to T. So in order to find this one, we could find Q, we could find the PQ. So this is our vector PQ. And we want to find the distance of QT. We could find this kind of like the projection, but we could do is use the area. Okay, we could find the areas, and from the area, this is a height. So we could find this is a base. Okay, so we could form a parallelogram. Okay, we know how to find the area of the parallelogram. So this is another point, PQ. We are going to write this one as S. Okay, so this is we create. So step 1, create a parallelogram. Parallelogram PQSR. So the P is just R0. So P is our R0, and Q is given R is just when t equals 1 on the line. It's 3, 2, 0. And for the s, we don't bother to find it. The reason for that is we want to find the area of this PQSR. It equals cross product base times height. So it will be just the PQ cross PR. So that's the reason we don't need to have the x, y, z coordinates for s. So PQ cross PR. Then from this one, we know the area also equals base times height. So the base is just a magnitude of PR. We have the 2 points already. We are able to find the magnitude of the B. Then we times H. Once we have this cross product, we just move the PR magnitude to this side. We are able to solve for the H. So H is our shortest distance from Q to PR. And now we are going to find the PQ/PR. So PQ is not point P, not point Q, but OQ take away OP. So it's point Q, 4, -1, 1, take away 1, 3, -1. So give us 3, -4, and 2. So 4 minus 1 is 3, -1 minus 3 is -4, 1 minus -1 is +1, so it's 2. Then we find the PR. So it's OR take away OP. And R is 320 minus 1, 3, -1. So x minus x, 3 minus 1 is 2. 2 minus 3 is -1. 0 minus -1 is +1, is 1. Then we are going to do the cross product. So remember that cross product, we use IJK, the matrix. So copy the PQ, the PR here. So for the I, we just cross I row and column out, then just do the cross times. So -4 minus 1 give us -4, then -4 times 1, -4 minus -1 times 2, -4 plus 2 is -2. This is I direction. So we could write more steps here. Okay, so I direction is -4 times 1 minus 2 times -1. Then J direction is we move the I to the back, continue. So the J direction cross J out is just 2 times 2 minus 3 times 1. Then the K direction cross K out is just 3 times -1 minus 2 times -4. So we are going to have the area equals magnitude of this -4 minus -2 is +2, so it's -2. 4 minus 3 is 1. And 3 times -1 plus 8 is 5. The x value is just a squared plus b squared plus c squared. Is the magnitude of that vector. Then we have square root 30. And we want to find the PR. So PR is this one. The magnitude is just a squared plus b squared plus c squared. We have square root 6. So area equals this one times base times height. 30 equals square root 6 times height. In order to find the height, we move the square root 6 to other side. Then the distance is 30 divided by 6 is 5. So therefore, the distance from Q to the line is square root 5. So that is all for today's lesson. What we have done is for 2 dimensions, we could use a formula right away. This is the equation ax plus by plus c equals 0. We sub in the point where we want to find the distance to this equation as a numerator, then divide by the magnitude of the direction vector square root a squared plus b squared. Then we find it. And for 3 dimensions, it's a little bit tricky. First thing, we need to create a parallelogram. And the parallelogram, we use t equals 0, t equals 1 to find 2 points on the line. And based on these 2 points on the line, we have 2 vectors for the parallelogram from the same point. So PQ cross multiply with PR give us the area of this one. Then we divide by the base, the magnitude of PR. It will give you the height. The height is the distance. So thanks for watching.